Hello everyone and welcome to lesson 5-7, solving proportions. In this lesson you will learn how to use cross products to solve proportions and use the constant of proportionality to solve proportions. Okay, so let's focus now on this key concept so that we can really start to build on our understanding. So we have the words. Okay? The cross products of a proportion are equal. The cross products of a proportion are equal. The cross products, okay, of a proportion are equal. Now, what do they mean by that? For example, here, A over B is the same as C over D. So they're saying that this equals this. They could be represented by different numbers, but this ratio is equal to this ratio. And I can show it here to you. I've replaced it with numbers so that I know that if I divide 4 divided by 2, okay, I'm going to get on this side, I will get 2. 4 divided by 2 is 2. And 8 divided by 4 is also 2. Which means these two ratios are equal. Now, here's what we mean by cross products of a proportional are equal. Cross products will be equal. 4 times 4 equals 16. And 2 times 8 also equals 16. So you can see that both, when we do cross products of a proportion, when we cross multiply, we're going to have an equal value. Okay, so 16, 16, and the ratios equals the same. They're both also 2. That's why I said equal there. So as we just did there, we just looked at a proportion, okay? And what that means is that a proportion is an equation. This is an equation because we have an equal sign, right? That it says this side is the same as this side. It's an equation stating that two ratios or rates are equal. This ratio and this ratio are equal. This is proportional. You can use the multiplication property of equality to illustrate an important property of proportions. The ratios, oh look at that, the same ones, okay? 4 over 2 and 8 over 4, as we have right here, are equal. They both simplify to 2 over 1, or just simply 2. And you can see it right there. 4 divided by 2 is 2 over 1, or 8 divided by 4. Or simplified, really. If we simplify, how many 4s are here? We have 1. How many 4s do we have here? We have 2. Here we see that we can, the steps they want to show you. So we have 4 over 2 is the same as 8 over 4, right? They want us to multiply each side by 2 times 4, which is the multiplicative inverse of our first ratio, the multiplicative inverse, right? Which would be 4 over 2. And if we multiply, you can see that we can cross-reference the 2 and the 2, okay? Here's what they mean by it. 4 over 2, as we have there, and we multiply it by the multiplicative inverse of 4 over 2, which is 2 over 4, okay, and we have 2 over 4, and then we cross-reference, and you know that those 2's are going to cancel each other out, and what do I have left over? I have 4 times 4, right? That's all I have left over, 4 times 4. And that's what they want us to do there. So they want us to multiply, and we have 4 times 4 left over, and then we do the same thing on this side, and now this time the 4's are gonna cancel each other out so that we have 8 times 2 left over. And there we have it. And you know that this is 16 and this will be 16. Here it is using variables. And here's what we mean. The products 4 times 4 and 8 times 2 and AD and CB, as you see there, are called cross products of the proportion. The cross products of any proportion are equal. And that's what we were trying to show you. 4 times 4, 8 times 2. Both equal 16. Cross products will help you when you use proportional reasoning to solve a problem. Just as in solving an equation, solving a proportion means finding the value of the variable that makes a true statement. So you're looking for a value of a variable that makes a true statement. This sounds familiar. Do you remember how we did this in 5th grade where we found the rule? This was what we practiced in the math boxes. Well, when you say finding the value of the variable that makes a sentence true, here we have a sentence. Whenever we go from circle to square, we're going to go down by this many. Well, we're supposed to find the rule, but when we write this algebraically, we write it as 28 divided by a number that we don't know equals 7. Okay, and there it is algebraically. So we're trying to identify the rule, or in other words, the value, okay, of the variable. this variable that makes the statement true. So what's the value of this statement? Well, I'm sure you've already figured it out, that x equals 4, right? You've already figured it out, so then if we were to do this, we would fill it out as so. 16 divided by 4 is 4, 1 divided by 4 is 4, 20 divided by 4 is 5, and so on. So you can use cross products to solve a proportion in which one of the quantities is not known. For example, we can have x over 15 equals 40 over 60. Okay, well we know that this is equal to this. What did we do to the 15 to make it 60? I'm sure you guys can tell that we quadrupled it, we multiplied it by 4. That means I have to multiply a number here by 4 to get 40. What number multiply times 4 will give me 40? And there it is. It's essentially the same thing we did in 5th grade when we were looking for the rule. Okay? Or we can simply look at the proportion and say, here I went down, I divided it by 4, so I must divide this by 4, and our answer should be x equals 10. To solve it using cross products, we would multiply these two, but you know, just for the sake of simplicity, let's simplify this. We know that they're both divisible by 20, and we have 2 20s here and 3 20s there. This is 2/3. It'll just make it easier to multiply. Now, if we were to do cross products, as it says here, cross products, I would multiply these two together, and I would say 15 times 2 is the same as x times 3. Okay? And what is it? Well, here I have 30, and then here I multiply the 3 times the number to get 30. And for a lot of you, this is very obvious. 3 times 10 is 40. Come on, Mr. Mendez, don't make this longer. But no, I actually want to show you the steps that you should do, because this will get harder later on. The numbers will get more complicated, the rational numbers we will use. These are nice whole numbers and easy to work with, but it's not always going to be this easy. So what you need to do is actually solve for x by isolating x. Let's solve here, and let's bring this 3 over to the other side. So it should look like this. 15 times 2 equals 30. Okay? That's what we have on that side. Equals x times 3. And now we want to isolate the x, so we must bring this 3 over to the other side. On this side, the 3 multiplies. We must do the opposite on this side. So if it's multiplication on this side, we must divide on this side. So then I bring my 3 over, and now I have 30 divided by 3 equals x. And finally, x equals 10. I know that was a longer way to do it. We could have just figured it out the first time we looked at it, right? But like I said, it's important to learn these steps to isolate the variable and invert the operation. Since we spent so much time in the previous slide, I think for this example you should pause and look it over on your own, and you can see that it's proportional. If I quadruple the 15, it's 15 times 6 will give me 90. So then, if I have to multiply by 6 to get this way, I must divide by 6 to get backwards. Or you could say it's b times 6 equals 66, which is 11. And you can see the process. But please, look how they use cross product, how they multiply, later divide, and then finally simplify. These are the steps that the book is showing you to use. And we can also implement decimals. And you can see, again, using cross products. Okay, they use cross products to multiply right there, and it helps us solve. Here they're not isolating the n as we did in my example. Here they're just dividing both sides by n so they can get rid of this n, and this is what you get. Okay, go ahead and try these examples on your own, and then check with me on the video. Please pause now. Okay, I hope you paused the video. Remember, we can cross products, so we would have here for 1a, we would have 20x, because I multiply those two together, equals, when you multiply 4 and 8, you get 28, right? 28. So 20x, so I must multiply 20 times a number that will give me 28. Well, I must multiply by at least 1 so I can have the 20. And what is 8 out of 20? 8 out of 20 is 2/5, right? 2/5, which is 0.4. So I would have to multiply 20 times 1.4 to get 28. Okay, I can do that mentally, but if you can't do it mentally, what you need to do is isolate the x right here so that it looks like this. You multiply on this side you must divide. So now it's going to look like x equals 28 divided by 20. And when you divide 28 divided by 20, you will get 1.4. For example B, you can do it the exact same way, 7 times 2 and 14 times c, so that you have an equation that looks like 84 equals 14c, right? You could do it like that as well. Or you could ask yourself, proportionally speaking meaning here I have a 14 and here I have a 7. Here I have what we call a half. 7 is half of 14. So, and it's equal to this ratio. So this one must also be a half. What's half of 12? Well, half of 12 is 6. Some of you might just be able to jump right to it and say C equals 6. And you know what? That's okay if you can do that, because that means you actually are making sense of this. You have math sense. Or we call it number sense. You have number sense and you're able to see into the equation. Over here too, if you were working with proportions, both these numbers have a number that can be divided into both of them. Yes, they both have the 2, right? They both have 2. You have 25 over 17, okay? If you were to multiply by 17s, you would get to 68, right? Here you have 2 17s, and here you have 4 of them. Okay, you could look at it like that. Well, if you remove the decimal, obviously you have to put the decimal back later on. But again, I'm trying to show you number sense. Here I doubled it. Obviously put a decimal. If I double this, I'm going to get 100, won't I? But then I must put my decimal right back in where it's supposed to go. So 6.8 over 10 is the same as 34 over 50. If you don't believe me, let's try it. Let's do the cross products. So I have 34t, and 6.8 times 50 is 340. I just go right ahead and I isolate my t the way I want to, and I bring my 34 over to this side. On this side is multiplication, on this side will be division. Remember, whenever you have a number and a variable side by side, the computation is multiplication. So multiplication on this side, division on this side, and it looks now like this. I get rid of it here, and it comes here. And 340 divided by 34 is 10. T equals 10, just as we did. Okay, for class, please put a star around this one. You can put it right next to it or around it or a circle around it, and do it on your own. And remind me in class to check it with the star and the circle around it so that I can add points towards your effort grade. This means that you are actually watching the video as you're supposed to. So please, this is your key answer, doing this one on your own and showing it to me in class.